Hi, I'm Andy Glass with Glass Impressions. In a previous collaboration with ToolsToday.com, we did a really nice cinematic video on this drill storage charging station. Now this is a product I've been working on developing the last few months, and we've gone through a couple iterations and finally settled on this design, and we've produced a really nice video with ToolsToday.com on their channel. On this video, I want to more focus on the production aspect and the process and workflow of actually producing the product. Now we sell this product as a flat pack shipped item to the customer, and they can go ahead and assemble. We include all the parts, all the hardware, all the adjustable shelf pins, so the customer really just has to screw the whole unit together. In addition to that, we sell traditional woodworking files that if you don't have a CNC, you can go ahead and make one using traditional woodworking equipment. On the other hand, if you do have a large format CNC and you'd like to make one, we sell the CNC files as well. So let's go ahead and I'll walk you through the workflow and the process reliability that we've kind of dialed in over the last few months in the R&D phase of this product. Hope you guys enjoy.
The drill storage charging station began as an idea. I then started 3D modeling the idea in Google SketchUp. Once I was happy with the first design, I then moved the vectors into Vectric VCarve Pro. Here we can nest the parts on our material and then apply tool paths needed to fully machine out the parts. We purchase our material in bulk and bring it into the shop with the farm skid loader. This allows us to get great pricing and avoid lifting each sheet of 5 foot by 5 foot Baltic birch. In this particular case, we are using 3/4 inch material. Right off the bat, you can see the automation advantage of the CNC machine. Micah is working on processing one piece of plywood while the machine is working on another. I am uncrating the new lift of material. Being this is a new lift of plywood, we always load the first piece of material on the machine and then use a set of calipers to get an accurate measurement of the material thickness. This is important to our joinery as well as the CNC performance. With the new thickness noted, I can edit the program while Micah works on the second piece of material that the CNC did earlier. With our machine turned on, home to our proximity switches, and the spindle warmed up, we can zero our Z-axis to the spoil board. After loading a sheet of material on the machine, we can turn on our vacuum pump, close the main valve, and watch the vacuum suck the material to the machine bed and gain vacuum to hold our material in place. With a simple press of the cycle start button and the machine jumps into action. My ShopBot CNC is equipped with an auto tool changer. We are going to use a 3mm carbide tipped brad point boring bit to drill 3mm holes in our material. These holes will be used to quickly and easily assemble the unit with screws. The brad point really makes a clean hole, and the flute geometry allows the chips to get ejected and cleared on the retract motion. We are plunging at a rate of 50 inches per minute. This could be increased a little bit, but we found it better to be slightly conservative and gain process reliability and not worry about the drilling operation. The next bit the auto tool changer is going to grab is another carbide tip brad point boring bit, but this one is 5mm in diameter. We are going to use this bit to drill all the 5mm holes for the adjustable shelves on the drill storage charging unit. We again are going to plunge at a rate of 50 inches per minute. Being this bit has a little larger diameter, we could comfortably increase the plunge rate with a little bit more confidence than the 3mm bit. Just like the 3mm bit, the brad point creates a nice clean entry and exit hole and ejects the bits for the next drilling operation. With all the drilling operations completed, the auto tool changer is going to grab the most important bit we are going to use today on this project. This is a 3/8 inch compression bit that has a spectra coating. This bit is going to cut out all of our parts utilizing production speeds and feeds. We are going to push this bit to Amana's recommended feed rate of 600 inches per minute. This is the fastest I've had this machine move to date. And being this is a through cut operation, the compression geometry is a must. This has dual geometry that pushes the top wood fibers down and the bottom wood fibers up. This drastically reduces, if not eliminates, tear out altogether. With the smaller parts the drill storage charging station has, the vacuum table doesn't have enough holding power to keep them in position. You can see the spindle going up and down in the middle of the cut. That is going to leave little tabs to keep the parts in place and all connected. This adds a little bit more work later in the process, but increases our process reliability and reduces damaged parts or the chance of breaking a bit. With the smaller parts and tabs, the machine has to decrease its speed before it hits a tab or a corner of the part and then increase after. This slows down our cutting operation but is necessary for the health of the machine. It isn't good practice to instantly stop and start your machine. The machine has internal algorithms to adjust these parameters according to your speeds and feeds that you input. This is especially important to maximize your speeds and feeds in this situation, as you lose a little bit of time as your machine needs to slow down and speed up at each tab or corner. With all the parts now cut out, the auto tool changer will load up another 3/8 bit, but with a downcut geometry. We are going to cut the rabbets and dados needed to quickly and easily assemble the unit. Being these operations are not through cuts, we don't normally need to worry about tear out on the bottom of the material. This type of operation calls for a downcut bit to push all the top wood fibers down, drastically decreasing the risk of tear out. This bit has a Spectra coating as well. We are slightly below the speeds and feeds of the compression bit we used earlier, but still extremely fast at 500 inches per minute. We have plenty of RPMs left on our 25,000 RPM spindle, but again, we want process reliability over speed. We model up a few vector lines and apply a pocketing toolpath in Vectric VCarve Pro to complete these joinery operations. The vector lines are as wide as the thickness of our material. Every time we get a new material thickness, we quickly modify our geometry and save it for future use. This bit provides an excellent sidewall and bottom cut quality to make the joinery flawless. With the rabbets on the two ends and the other dados completed, the CNC moves to the top of the 5 foot by 5 foot Baltic birch plywood. Here we have the top and bot aligned for the unit. We aligned them in Vectric VCarve Pro and made a single tool path for the vertical partitions dados. This is another great example of how a person can save time in part layout and CAD/CAM shortcuts. It may not seem like much, but we are making hundreds of these. A little bit here and there really adds up. With our CNC operation complete, Mike and I scoot the milled piece of material on our work table. This allows us to clear the CNC machine and instantly get the machine working on another sheet of material. After we load a new piece of plywood on the machine, I can go ahead and get that set up and click cycle start. Micah is then working on processing the previous sheet on the work table. He uses Ryobi's 18-volt oscillating tool to cut through all the tab parts. He places all the parts on a cart to make moving them to the router table easier. When Micah moves to the router table, I follow behind him and clean the work table off in preparation for the next sheet. We have a great workflow and can go from a sheet of plywood to milled parts ready to be boxed every 31 minutes. Then we head over to the router table and use a carbide tip flush trim bit to flush trim the tabs. We adjust the height so it's right above the tabs to allow the bearing to ride along the plywood even when a dado or rabbet is there. Either myself or Micah will take 4 parts and run them through a drilling process at the drill press. These are an extra feature that we took advantage of some dead space on the plywood. These are perfect for storing all your frequently used bits. You will see a picture at the end of the video. In preparation for packaging, we print out 2 pages that we include in the packaging that shows the unit exploded with the parts labeled, as well as a QR code to an assembled video. This is the first time we packaged a unit up in our custom boxes, and they were a little chilly, so our gum tape wasn't sticking the best. We're also thinking about getting some banding material to help give extra support to the box. To put this unit together is very easy. In the CNC process, we added 3mm holes to allow for the included screws to secure the parts together. Being we have an 18 gauge brad nail gun in the shop, we are going to hold the parts together with that first, then come back and drive the screws. This unit with glue, brads, and following up with screws can be assembled in under 15 minutes. CNC technology is so precise that all the parts come out exactly how you designed them in CAD, which means your unit is self-squaring and comes together quickly. The back of the unit really squares up the unit nicely.
Well, I hope you guys enjoyed the video. I hope you guys enjoyed the product itself. This is something that I've wanted to do for a long, long time. And now that I finally have a large format CNC, just like this ShopBot tools, 5 foot by 8 foot CNC, it has a vacuum table and an auto tool changer. It's something that's just really a production powerhouse. And bringing this in my shop has brought so many possibilities, from cabinets to custom closets to being very competitive in the product realm of things. I could not bring this product to market without the CNC here in my shop. Now, this was a fun product to R&D. This is about the 5th or 6th rendition of or iteration of this product. More so on the design, but also on the workflow, how we hold the parts, how we nest them, how we process them after they come off the CNC. We've done a variety of different work holding techniques and ultimately have scrapped those parts because they didn't hold down. Now, the vacuum table is a great option for those larger cabinet parts, but when you get into stuff that are very small parts that we have in this drill storage charging station, the vacuum table just can't hold it down and keep it in place. So in the video, as you saw, we've had to do the tabs. Well, we've tried to do the onion skin technique, but just ultimately it just doesn't work for what we're doing here. And we've developed a process reliability. When I load this 5 foot by 5 foot Baltic birch on the CNC, I want the confidence where I can hit go or cycle start. The CNC takes over and cuts all the parts I need. I want to be able to process the previous parts or packaging them up or doing something that I know that I can walk away from this CNC. I still can be in earshot in case a bit breaks or something happens that we're not aware of. But ultimately, we want to be able to make sure that the process is nice and smooth and we can go ahead and just completely ignore the CNC until it's done and we can process those parts. Let us know below if you have any questions, comments, or concerns. We'd be happy to provide some feedback, answer any questions you may have. Follow Glass Impressions, toolstoday.com, and ShopBot Tools on social media as we have a ton of CNC and woodworking content. I'm Andy Glass with Glass Impressions. Thanks for watching. I'll see you next time.